Hi there, Mr. Muhammed is here. Welcome to another tutorial. This is Oxford Complete Mathematics book for IGCSEs. In this tutorial, I'm going to solve 5 important questions in this set of exercise. The ideas from these 5 questions will help you to do all the other questions on your own. Let's get started with question 7. An aircraft flies 400 kilometers from a point O on a bearing of 25 degrees and then 700 kilometers on a bearing of 80 degrees to arrive at B. The diagram of this question looks like something like this. The question starts at point O. The journey of the aircraft starts at point O. Let's say this is point O. Okay, since the question is about bearing, so notes are required. Let's say this is the north of point O and we need an angle 25 degrees. Let's say this angle is 25 degrees, 400 kilometers. Then this distance is 400 kilometers. Then the aircraft goes to another point, but the name of this point is not mentioned in the question. So we don't name this point. We just know it's a point. And since we have another bearing, which is 80 degrees from this point, we need to mention that we need another north. The north of this point, north is always like this, and then an angle 80 degrees. An angle 80 degrees will be like this, using a straight line. Okay, here. 80 degrees will be something like this, and this distance is 700 kilometers. Since the question is not about scale drawing, we don't draw to scale, we don't spend time on the diagram, but it must be something that has a meaning according to the question. Now we have this, and finally the aircraft goes to point B. This point must be B. Now, part A, how far north of O is B? How far north of O means we need to know how far is this point. How far is from this point until we reach B? This much. How far is this, or how long is this line? This line, we should find the length of this line. What can help us to find this length? We need to complete 2 right-angled triangles. Then we're going to complete this right-angled triangle like this. And here we got the first right-angled triangle, and the second right-angled triangle will come here. Yes, these 2 right-angled triangles will help us to find this distance, which is the answer of part A. Now, as you see this distance until here, we can use this triangle, and for the rest we can use the other triangle, because this distance is the same as this part. Now, it's given in the question that this angle is 25 and this angle is 80. This is the right angle. This 400 is hypotenuse. This is the right angle. This 700 is hypotenuse. According to this angle 25, which side is missing? Adjacent. Which side is given? Hypotenuse. So it means we need to use cosine of 25. Cosine of 25 is equal to adjacent A over 400. Then to get rid of this 400, the cosine of 25 should be multiplied by 400. Then using my calculator, cosine of 25 times 400 straight away gives the length. 362.5, we can simply say 363. Then A is 363 These are all in kilometers. This is also in kilometers. We got this much is 363. Let's get the other one. Again, what's missing in this triangle according to this angle is the adjacent side. And the adjacent for this, again, cosine should be used. Cosine of 80 is adjacent over 700. Again, to get rid of the 700, the cosine of 80 should be multiplied by 700 using a calculator. Cosine of 80 times 700 is equal to 121.5. So the other part is 121.5. We can just say 1.121 or 122, both fine. Now we got the answer of part A. By adding these two parts, we will get how far is B on the north of O. 363 plus 121, it will be 484 kilometers. In part B, we're going to do something similar to part A, but this time we have to calculate this length because this time it's on the east of O to B. We need to calculate this. Again, we're going to use the same triangles, but this time from here to there, that covers this much in this distance, and from here to there, that covers this much in this distance. So it means this time we are going to find the opposite of angle 25 and the opposite of angle 80. We can do this by using sine. Sine of 25 is equal to opposite over hypotenuse, opposite over 400. Then to get rid of the 400, to get the opposite, we multiply the sine of 25 by 400. Then sine of 25 is equal to this times 400 is 169. This opposite is 169 kilometers. To get the other opposite, again, we're going to use sine of 80 is opposite over 700. Then to get rid of the 700, to get the opposite, we need to multiply sine of 80 by 700. That gives sine of 80 is equal to this times 700. It's 689.3. Simply, it's just 689. Now add these two lengths to get the total length from the east of O to B. 169, 689 plus 169 is equal to 858.3, which is just 858. This is 858 kilometers. And finally, part C, find the distance and bearing of B from O. This time, I'm going to use a simpler diagram because we know this length and we know this one. These two sides will help us to find the angle, which is the bearing of B from O, and then we can find the hypotenuse. Simply, we can say this is point O, this is point B. This length is similar to this one. So this length is 858 kilometers, and this length here is 484. Now we know two lengths. The angle between them is missing. These two lengths are opposite and the adjacent. This angle is missing, which is the bearing of B from O. Let's call this angle T. And according to T, we have opposite and adjacent. So we're going to use tan. Tan of T is equal to opposite, which is 858, over adjacent, which is 484. Now, Tan inverse of this fraction will give us the angle T. Angle T is 60.5 degrees. We got angle T. Now, how can we get the hypotenuse? Since we know the angle, finding hypotenuse is easy. We can use either sine or cosine because they both contain hypotenuse. Let's say sine of T, which is 60.5, is equal to opposite, which is 858, over hypotenuse. The hypotenuse is missing. Hypotenuse is the total distance between O and B. Now sine of 60.5 is equal to 0.87, and then 0.87 is 858 over h. Now we need to flip them and then multiply by 858. It means 858 simply is divided by 0.87. That gives 986.2. It's 986. The distance is 986 kilometers, and the bearing is 60.5 degrees. Question 7, done. Question 9, for the points A is 50, B is 73, calculate the angle between AB and x-axis. Let's just draw an xy axis. Okay, let's say this is an xy axis, and mark these points. 50, 5 in the x-axis, 1, 2, 3, 4, 5, and 0 in the y-axis. 50 is here. This is point A. And point B until here is 5, 6, 7, and 3. Point B is 7, 3. So this is point B. Now we need to find the angle. The angle between AB and the x-axis means we need to find this angle. To find this angle, we need to complete the triangle. Let's complete this triangle. To have a right angle, then we will be able to use sine, cosine, or tan, trigonometrics in general. Now, we complete the right angle triangle. Here is the right angle, which is 90 degrees. According to the xy axis, this distance is 2, and this distance is 3 units. We need to find this angle. Now, according to this angle, let's name this angle T. According to this angle, what's given? The 3 is the opposite and the 2 is the adjacent. It means we can use tan. Tan of T is equal to opposite over adjacent. Tan of T is equal to 3 over 2. Now we need to use tan inverse of 3 over 2. That gives the angle. 3 divided by 2 is equal to 1.5. So tan inverse of 1.5 is equal to 56.3. So the angle T is 56.3 degrees. Question 10 has the same idea. This time we're going to plot 2 points. 0, 2, 0, 2, 0 in x-axis is here. 2 in y-axis is here. So this is point C. And 5 in x-axis, 9 in y-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will come around here. This is point D. Now we need to work out the angle between CD and the y-axis. It means this angle is missing. Now we need to complete a right angle triangle, so we can extend this to here and extend this. Now as you see, we have a right angle, and according to xy axis we know how long is this side. 1 2 3 4 5 6 7. This side is 7 units long, and the side is 1 2 3 4 5. The side is 5 units long. Now according to this angle we have opposite and adjacent. Again we need to use tan. This is for question 10. Tan of, let's name this angle P. Tan of P is equal to opposite over adjacent, 5/7. Now we need to use tan inverse to get P. Tan inverse of 5/7. Tan inverse of 5/7. It's 35.5. Angle P is 35.5 degrees. This is the answer of question 10. Question 11. This time we have 3 coordinates, and we need to calculate the size of the angle between them, which is angle A. After we plot all the 3 points, question 11 point A is 3 0, 3 in x-axis and 0 in y-axis, means this is point A. Point B, 5 2. 1 2 3 4 5 and 2 up. It's right here. This is point B. And point C is 7 -2. 1 2 3 4 5 7. -2 goes down 2 steps like this. Now let's join them with straight lines. Okay, how can we find angle BAC? Means angle A. How can we find angle A? This time we're going to repeat the steps of question 9 and 10. Complete a right angle triangle. Because this is not a right angle, complete a right angle triangle. So it will come here. We're going to draw a straight line here. Now we have a right angle triangle with angle A. How big is this line? This distance is 2 units, and the other one is also 2 units. Now we're going to work out this part of angle A. We know 2 sides. According to this angle, these 2 sides are opposite and adjacent. We're going to use tan. Tan of this part of angle A. This part of angle A, let's call this part X, and the other missing part of angle A, Y. Now this part of angle A, let's call X. Tan of X is equal to 2/2. Tan of X is equal to 2/2, which is equal to 1. Let's see tan inverse of 1. Tan inverse of 1 is 45 degrees. Means X is 45 degrees. But this part of angle A is 45 degrees. Tan of Y again, let's complete a right angle. Here, if I join point C to the x-axis, I will form a right angle here. Got it. Now, how long is this side? This side is 2 units, and this side from angle A to here is 1 2 3 is 3 units. Again, according to angle Y, let's say, what's given is opposite and adjacent. Again, we need to use tan. Opposite is 2, adjacent is 3. Tan of Y is equal to 2/3. Let's calculate tan inverse of 2/3. Tan inverse of 2 over 3. Tan inverse of 2 over 3 is 33.6. So y is 33.6 degrees. Together 45 plus 33 is equal to 78.6. So angle A, we can write it like this. Angle A is 45 plus 33 is 78.6 degrees. Completing right angle triangles is the crucial idea to do these questions. Question 13. From the top of a tower of height 75 meters, a man sees two goats, both due west of him. If angles of depression of the two goats are 10 degrees and 17 degrees, calculate the distance between them. Oh. Firstly, angle of depression is an angle like this. This is angle of depression. So we're gonna draw two right angle triangles, and the object is here, the object that the man is watching or anyone. The object is here, and here is a right angle between the side which is perpendicular to the eye and here the object. Now the first one, the angle of depression is 10. Let's say the man is on a building 75 meters, and on this side, on the west, this is the angle of depression, and this angle is 10, and the height of the building, which is here, is 75. This height is 75 meters. This is the height of the building. The man is right here. It's on a building, and it's 75 meters high with the building. Now, this angle is 10 degrees. We know the angle. One side is given, which is the opposite of the angle, and we need to find this, the adjacent. To get the adjacent and the opposite is given, we don't need hypotenuse. Tan could be used. Tan of 10 is equal to opposite, which is 75 over the adjacent. Opposite of 10 over the adjacent of 10. Tan of 10 is equal to 0.17. 75 divided by the tan of 10 is equal to 425.3. Let's say just 425. This distance is 425 meters. And the same man on the same building sees another goat. Let's say goat 1 is here, and goat 2 is around here, and this time the angle is 17 degrees. The same man on the same building is here, and the right angle is here. So the same man on the same building sees another goat. This time we need to calculate only this one. To get this one, we know the angle. The triangle looks like this, and this angle is 17 degrees. This height is 75 meters. We need to work out the adjacent. We can use tan. Tan of 17 is equal to 75, which is the opposite, over adjacent. Now, the 75 should be divided by the tan of 17 to get straight away get the adjacent. 75 divided by tan of 17, that equals to 245. This A is equal to 245. Now the distance between the goats is here, which is this distance. We're going to subtract 245 from 425, which is equal to 180 meters. Thank you for watching.